This podcast is on solving equations which contain radicals. We're going to be using the 5 steps here that I've shown off to the right a little bit. Step 1 says isolate a radical. That means to get it by itself on one side. Square both sides. That's going to remove the radical from the radical that you isolated. Repeat steps 1 and 2 until all radicals are removed. We'll see that in example 2. Solve the resulting equation by whatever means you have. And then step 5, you see the all capitals, check your answers. This is because as we're squaring both sides, we're very likely to, or we're quite possibly will introduce certain answers to the squared equation that were not answers to the original equation. So it's very important on these radical equations. It's kind of like the rational equations where you check your answers because all answers may not be legitimate. Okay, let's get started. In example 1, we don't really have to isolate a radical because the radical square root of 6x plus 1 is already isolated. And I might mention here these are radicals in the traditional sense of meaning the positive number you square to get 6x plus 1. Okay, let's begin. So we've got a radical isolated already. Step 2 says square both sides. So I'll take the square root of 6x plus 1 squared is equal to x minus 1 squared. So this on the left, this would just be 6x plus 1. And on the right, to square that, you have to FOIL it. So that's going to be x minus 1 times x minus 1, which is going to give you x squared minus 2x plus 1. So that's what will be on this side. Okay, we have done steps 1 and 2 until all radicals are removed. There are no radicals left, so let's just proceed to solve what remains. I'm going to move my 6x to the other side by subtracting 6x from both sides. I'm going to remove my 1 to the other side by subtracting 1 from both sides. And what I end up with on the right is x squared minus 8x, and on the left is 0. Now that expression on the right is a factorable expression. We could use the zero product theorem here. We've already got a 0 on one side, so let's make a product on the other. Just take out the common factor x. That's always what you do first when you factor. And I end up with the equation x times x minus 8 equals 0. So by the zero product theorem, either x has to be 0 or x minus 8 has to be 0, which means x is equal to 8. So there are 2 proposed solutions. So we've now done step 4, solve the resulting equation. Step 5 in caps says check your answers. Well, let's check them. Suppose I put 0 into the equation. Then each empty hole would get a 0. So on the right I'd have the square root of 1. On the left I'd have the square root of 1, which is 1. And on the right I'd have negative 1. That is not true. A solution of it is a value of x that makes the original equation true. So that is not a solution. We try x equals 8. If I put in an 8 instead of a 0, I get on the left side 6 times 8 plus 1 is the square root of 49. That's 7 is equal to 8 minus 1. That is true. So that solution checks and I get the answer x is equal to 8. Okay, let's try the second one now. Notice in example 2, no square roots are isolated. So the first thing I'm going to do is isolate a square root. And I'll do that by moving the square root of x minus 2 to the other side. And the second step it says is to square both sides, so I'll square this square root, but on this side, again, I'm going to have a FOIL because I've got 2 terms separated by that minus sign. So on the left, I just get 2x minus 3, but on the right, I have to FOIL that. So that's going to look like this, square root of x minus 2 minus 1 times square root of x minus 2 minus 1. And the square root times the square root will give me x minus 2. And the last term, -1 times -1, will give me +1. So what goes in the middle? Well, that would be the inside product plus the outside product. The inside product is -1 square root of x minus 2. The outside product is -1 square root of x minus 2. So when I add them up, -2 square root of x minus 2. Well, it says repeat steps 1 and 2 until all radicals are removed. So I have to isolate a radical again. There's only one radical left. So to get it by itself, I'll subtract x from both sides. I'll add 2 to both sides. And I'll subtract 1 from both sides. On the left side over here, 2x minus x is x. -3 plus 2 is -1. Minus 1 more is -2. On the right side, the x's, the 2's, and the 1's are gone, so I'm left with just -2 square root of x minus 2. Now, technically, to remove that radical, I'd have to divide both sides by -2 here. I could certainly do that, but it's unnecessary, because when I square this side, I'm going to get -2 square root of x minus 2 times -2 square root of x minus 2, which is just going to be +4 times x minus 2. So that's going to be something that I can handle very well. No center term was produced because this is just one term. It's not two terms. That's why we got no center term and why we got no square root. So I'll just square both sides here. X squared minus 4x plus 4 is equal to, and we already see what happened when we squared the other side, 4 times x minus 2, which is the same as 4x minus 8. Okay, well, we've done steps 1 and 2 until all radicals are removed, so now we solve what remains. I'm going to do that by the zero product theorem, so I'll subtract 4x and add 8. Subtract 4x and add 8, and I get on the left x squared minus 8x plus 12, and on the right I get a 0, so there's the 0 of my zero product theorem. And to make a product, I factor, and this turns out to be a particularly easy factoring. X minus 2 times x minus 6, and just to make sure it's the factoring, compute that center term. -2x plus -6x does give us -8x, so the zero product theorem leads us to the answers x equals 2, x equals 6, and now we have to check them in. That's the big step 5. Notice the capital letters there. Check your answers. You're never positive about these things until you actually check the answer. So take the x equals 2, put it into the first radical. And let's see what happens. If I put in the x equals 2, this is 4 minus 3, so that's the square root of 1, which is 1. If I put the 2 in here, I get the square root of 2 minus 2. Well, that's just 0, so I get 1 equals -1. Well, that's not true, so that's not a solution. Let's try x equals 6. I'll put the 6 in here and the 6 in here. The first one is the square root of 12 minus 3. Well, 12 minus 3 is 9. Second one is the square root of 6 minus 2. That's 4. So I get the square root of 9 minus the square root of 4 is -1. Well, actually, the square root of 9 minus the square root of 4 is really +1. So that turns out to be not true. So this problem actually had no solution. And that completes the podcast on solving radical equations.